This conference will now be recorded.
Good morning again. Okay, so what we will do today is yesterday I've given the introduction about the course, introduction about the performance engineering, what are all topics we are going to cover, what application we are going to use it for our engineering activities. All these things I have given a walkthrough, right? If any of you have any questions, please let me know. We can discuss initially itself, and then I'll go over to the session. Anyone have any questions? No problem. Okay, so what I will do today is for you guys to maybe a little bit understand about the way we are going to learn or understand each of the topic. I'm just going to randomly pick a topic in this list, and then I'm going to go over for next 20-30 minutes so that you will get to know the uh, kind of training you will get, and also the style of teaching as well, right? For just you get for you to get comfortable before you get into the course. Okay, so I'll pick Java threads for today, and then I'll go over the concepts. I'll go over the configuration of Java threads, and then what are the various states of thread. We'll go over both conceptually and also practically. Okay, maybe many of you know the threads are kind of a task handler, right? Um, you in any applications, you're going to have a CPU, a processing power. You're going to have memory, which is going to store things temporarily in memory during an application lifecycle. And in a web application, you open your browser and you type in your website, say hdfc.com or icicibank.com, and then the request comes into from your browser to your server. Okay, and then once it reaches a server, every request will be handled by a thread, right? You just think that it is going to be an handler. It is going to receive your request, and it is going to uh, pass it on to the JVM, and it is going to get processed. So you can just think that it is going to be an handler. Handler is nothing but it is going to receive the request. It is going to take care of your request until the response is sent back. Okay, and there are going to be multiple threads available in your server to handle concurrent request. Right? Obviously, you might be running in production. HDFC.com will be accessed by say thousands of users concurrently at the same time. There will be 1,000 logins or 1,000 people trying to do some transfers, looking into statement. Um, so all these transactions are going to happen concurrently to the server. All these requests will be handled by threads, and it is going to be limited by the number of threads as well, right? So you're going to configure the threads in such a way that you can handle the required load. That is the definition of a thread to keep it very simple. Okay, what I'll do is I'll explain the thread in maybe a little bit simpler way so that you can understand the concepts of how threads are created, how threads are what are the various states of thread. Okay, see, you all are, we are, in fact, we all are now very much use all these Swiggy, Zomato, Zepto kind of a uh, uh, food apps, right? Food apps are all common items are now being delivered through these Swiggy channels or Zomatos. Okay, so we all know how it operates, right? You open the app, you order food, and then it is getting delivered. And we all know there are going to be a lot of people employed in Swiggy or Zomato, the delivery person, who are going to be operated in that particular area. Right? So there are going to be say 5 or 8 or 10 Swiggy delivery person who are going to be, initially they might be, say, idle. They might be, say, near to some of these restaurants, the parking lot, just waiting for the orders to come in, right? So all these delivery people who are been employed will be waiting idle state initially without any work in the parking lot. And then say a person is ordering a Swiggy through an app for a particular restaurant. The request will be assigned to a particular delivery person who is free. And then what he will do, he will go and wait till that food is getting processed, and then it will once it is done, he will receive that and he will deliver it at home. Same thing happens for the other people as well. Whoever orders and whoever is free, that request is going to get that delivery is going to get assigned to a uh, particular delivery person, and he is going to repeat the same thing. So what happens is, in a round robin, these delivery is going to get assigned, and the Swiggy delivery people will be in a um, idle state for some time, depending upon the demand, and then you will be busy, you'll be delivering it. That's how this life cycle is going to be in a daytime, right? In a particular day, in a particular peak hour, and what happens is, see, in the morning, maybe around 8 to 10, or evening around 6 to 9 is a peak hour, right? Other than that, maybe evening 3 to 5, or morning 10 to 12:30 or 1:30, we don't see a lot of orders, right? So what Swiggy will do is, they will just employ, say, 10 or 20 people in the peak hours, and maybe in the non-peak hours, they will have just 4 or 5, right? More of a part-time. That's how they handle the peak hour request and the non-peak hour request. Okay, so that's a typical life cycle of a Swiggy delivery channel. Okay, now let's just for a comparison, not an apple to apple comparison, but we'll just compare this with the application threads. Okay, here the application threads are similar to your delivery person. Okay, initially when the application is get started, your threads are going to get started, and until there is a request coming in, all these threads are going to be idle, right? Idle, or uh, we also call it as a parking state. Okay, similar to the Swiggy people waiting in the parking idle, we also call this as a parking state, idle or parking. Okay, and then when a particular when a person opens a browser and then type in hdfc.com and do some operation, the request will be assigned to a particular thread. So depending upon number of requests, the threads will get busy, threads will get idle, threads will be running. It will be just going on between these different states, right? And to handle the peak hour or non-peak hour, in Swiggy, what I told is, in the peak hour they might employ 10-15 people. In non-peak hours, they might just have 5 people. Similarly, here as well, we will be able to go and tell the server, I need maximum of, say, 100 threads, minimum of say 20 threads. Uh, Only difference is, here server will handle it dynamically, right? You no need to specify peak hours, non-peak hour. Depending upon the incoming traffic, all of a sudden, if the traffic is high, it will spin off additional threads. Initially, JVM will get started with the 20 threads. It will keep running. When it sees that the thread utilization is very, very high, lot of requests is coming, then it will spin additional 5 threads, 10 threads, 20 threads. From 20, it will go 25, 30, 40, 50, maximum up to 100 only. Okay, because you're given maximum as 100. And again, if there is server is not busy, when the application is not receiving a lot of requests, again the server intelligently will shut down those additional threads to a minimum level of 20. So always it is going to be between 20 to 100, not more than 100 or not less than 20. Okay. Yeah, only difference is, in Swiggy, you will not have that flexibility. You just cannot have people in reserve state and call them and ask them to support you, right? So instead, there will be a fixed people employed in the peak hour, 20 people. In the non-peak hour, it will be a fixed people of 5. Wherein here in the application context, you have this flexibility. Server can intelligently spin off additional threads on demand, right? Yeah, that's a simple analogy between the way threads operates and Swiggy operates. I thought it will be easy for you to remember if we go with these kind of a comparison. So it's not apple to apple, but it's more of a us to understand and remember. These are the various states. I was speaking about various states of thread, right? In the life cycle, from the moment your JVM is started, the thread is going to get created. Okay, the moment it gets created, we call it as a new. The thread status new. Okay, and then it will go into a runnable state or a parking state, which means it is created and then um, um, it is in a state where it can receive request. It is in a runnable state. It can run. It is runnable means it can run whenever it is required. It is sometimes we call it as a runnable or parking. Both are same, which means I'm waiting to receive order. I am created now. I'm waiting to receive order. Okay, and then once it receives the request, it will go into a running state where that is where it will consume CPU. It will do your actual algorithm. It will execute the login functionality or logout or order some uh, uh, transactions, view statements, transfer funds, whatever algorithm that is going to get executed. That time the thread will be in a running state. Okay, so runnable and then running. Once it is execution is completed, again it will go to a runnable state, which means it will again go to a idle state. So it will toggle between runnable, idle, parking is all same. Runnable, idle, parking is same. Running is actual running. So it will get toggle between runnable and running. In between, there is a state called waiting. Okay, waiting means you got a task. In between, while you execute the task, you are on hold. Okay, hold means it can be for multiple reasons. That can be intentionally developers might have written some thread.sleep in the code, because of which your thread might be just holding or waiting for few milliseconds or few seconds. It can be because there is a um, block or a lock. Your thread is logged for a particular code or a method, because of which it is logged. That is also a waiting state, which is not a good state. Okay, we'll talk about those locked state, how to determine the locked state, how to take the thread dump to determine the lock state and all in detail later. But one of the state is waiting. Waiting can be because a developer has written the thread.sleep for few milliseconds or a second, it might wait in a waiting state. Second is something called blocked. We call it as a logged state or monitor. Okay, both are interchangeably. Some of the tools will say logged, some tool will say monitor. Okay, and then it will again go back to the running. So all three states can be getting toggled for a particular thread. A task is assigned. Before task is assigned, it is in a runnable state or a parking state. Task is assigned, it is in a running state, and then in between it can go to a waiting state, and again it can come back to the running state. Finally, if the usage is less, additional thread that is getting created will get terminated. Okay, so these are the various states of the thread. Okay, we should remember these states of the thread. You can probably remember this the way Swiggy operates, so that in interviews you will keep getting these questions about the states of thread. What are the various states, and what is waiting, what is blocking, what is runnable, what is running. Okay, what I will do is for you to visually look into this, right? For you to better understand it in detail, I'll open our e-library application, and then I'll open few tools, and then we'll also go and configure the threads, and then see how these states of thread appears. Okay, so I'll open few tools one by one. The first thing is I'll open our application. Okay, let me go to the e-library application. Okay, the installation of Tomcat, deploying your war file, and then setting up your application server. So that I have a separate video which is very simple anyway. You can follow whatever I'm doing it now, and also you can look into the video for you to set it up. Okay, so I'm going here. I'm opening the Tomcat. So this Tomcat folder is available in the Google Drive. Okay, you can download the Tomcat folder, and then if you go to the web apps, you will find the war file. Okay, whatever war file I give it in the drive, you can download it to this folder. Remember, the war file name is elibrary.war. E and L are caps. Okay, just a few simple typo mistake will not allow you to access the application. So just remember, when you download, even if the name is different, like I might have given e-library underscore response time issue, e-library underscore thread issue, e-library underscore memory issue. When you copy it to the webs folder, always rename it to elibrary.war. Okay, I'll delete other war files. Okay, now what we'll do is we'll go and before starting the server, okay, we'll go and check the configuration of your server in terms of thread. Okay, go to the configuration file, open this server.xml. Okay, and if you come down, yeah, if you come down, I have given the port in which the server has to run. You can, if you want to change, you can change it to 8080, 8081, 8082, whatever you want. By default, I'm given as 8083. Okay, and then what I will do is I'll go and change this to, for now I'll give the minimum thread as 4, and then maximum thread as say 6. Okay, and then I will save it. What is the maximum value we have to give, what's the minimum value we have to give for the application? Typically that is going to be part of your JVM benchmarking, which I will talk about it later. Be depending upon the requirement, depending upon your response time, depending upon your CPU usage, depending upon your heap usage, we have to configure the minimum and maximum. Okay, so there are a lot of things that needs to be factored in before we finalize the maximum and minimum, which we will learn later. But for now, for our just understanding, I'm just keeping 4 and 6, very small value. Okay, and I've saved it. And similarly, I will also open the bin, go to this catalina.bat file. This is where we go and configure your heap. Okay, so this I will open with okay. We come down. Okay, so when you in your Tomcat, when you download it from my drive, okay, first time, or if you're going to download from Tomcat from the website, uh, you will not have all these settings. Okay, so you don't need to worry about it. Okay, if you download it from my drive, then what you need to do is, for initially, just go and delete all these things. Okay, all these things which I'm highlighting it, just delete it. Just have this alone, the heap alone. Okay, because here I have given some commands which will point to some directory, D drive, D drive. So if you don't have this directory, Tomcat will not start. It's a typical error that people face. Okay, so when you set it up, just remember that I have given this all this instruction in the separate video also. But since you are listening, please note that all these has to be removed. Okay, and then you can just keep probably 400 MB as minimum, 1000 as the maximum. Again, don't worry what to set, why to set and all, we will discuss later. For now, for our exercise, for just our analysis, I'm just keeping 400 MB and 1000 MB is a minimum heap I'm giving to the application. What is heap? Why we need to give all these things? What is min, what is maximum? All these things we will be learning it in detail. Okay, but this is a command. This is the parameter where you can pass on how many what is a heap, initial heap that you have to give to JVM, and what is the maximum it can go up to. Okay, that alone you change it. All other things you can remove it. All these things you just delete it for now. Okay, and then save it. Once the thread configuration is done, once the memory heap configuration is done, then you can go and start your server. Okay, so once let it run parallelly, I'll open Jmeter. Jmeter reason is I'm just going to run some few requests concurrently for our understanding. So I'll go to where is my Jmeter? Yeah, I'll go to here. I'll open the command prompt. Let it start. The application is started. I will open the there's a tool called JVisual This is also available in the drive for you to download. Okay, you just need to download that JVisual You need to just extract it. You will get this folder. Okay, you will get this Visual VM folder. Open it, go to the bin, and then open this Visual VM. Okay, so I have my application started. I have my Jmeter opened, and I have my Visual VM opened. Okay, so Visual VM is one of the monitoring tool like JConsole, right? For Java monitoring, we can use JConsole or JVisual VM. Here, it will automatically show all the Java application that is running in my machine. Jmeter is a Java application. It is also showing here. We are having this our Tomcat E library is showing. Just double click this Tomcat. Okay, and go to the threads. And then if you see here, um, we have given uh, your 8083 port, right? With the thread minimum as 4. If you see here, in HTTP 8083 executor 1, 2, 3, 4. Only 4 threads are created, right? And all the 4 threads are in orange color. The orange color is nothing but, if you see the right bottom, the orange color is parking or runnable. The threads are created and it is waiting for the request to come in. So it will be in a running state, or sorry, it will be a runnable state or in a parking state. All 4 are now in parking state. Okay, now what I will do is, let me check whether the application is working fine. I'll go and open the localhost 8083 library, and then I will log in. So moment I log in, right, I'm sending a login request. Now you will see one of the thread is picking the work. Physical executed 2 randomly. Now it picked the work. It is now in a running state, green, running state, and it is going to a gray, sleeping state. Again, running state. Running, sleeping, running, sleeping, running, sleeping, and then now again it went back to the parking mode because the login is completed. So login is completed. There's no the request is completed. So now again it went back to the parking state. Right now, if I go and run this test, I'll just very small test. I will run it. Okay, with a few users. So I'm opening my Jmeter script, which is also going to be available in the drive. Okay, what I will do is I'll just say run a test for say 3 users. Okay, and then what I have here is I have homepage, and then I have a login, and then I have view librarian. Only 3 transactions I have it. Okay, so I'll just run the 3 transactions with 3 users. We'll go here. Now all the 4 are in parking state. Now you will see one by one it will start picking the work. The executor third is now having is in running state, 4 is in running state, 1 is in running state, right? So the all these threads will pick the work randomly, and it will go between running, sleeping, parking. If at all there is any block or some kind of a wait, it will also go to the waiting state. Sorry, to the monitor state. Okay, so all the 4 threads are will do this, take this task randomly. Okay, now what I will do is I'll increase the user count. Okay, now since I have given see in our thread configuration we are given minimum as 4, maximum as 6, right? Now we will see how additional threads are going to get created. When the JVM started, it is given only 4, not 6. Correct. Only 4 threads are there in the server. Now I'll go and say I'll run for say 8 threads, 8 users. Okay. Don't confuse between this thread, what you see in Jmeter, and this thread. Jmeter, since it is a Java-based application, they've used these terminologies. Okay, but just since you are performance testers already, right? Just think that it is a concurrent user. Number of concurrent users is 8, and then I'm going to run this. Okay, I'm running this. If you see here, at some point of time, it will create. Yeah, so if you see here, 1, 2, 3, 4, 5, and 6. 5 and 6 is also now created. In addition to the 4 threads, which was originally there, 2 threads are created now, and all threads are now actively doing some work. Okay, so the server is now um, looking into the traffic, looking into the number of requests that is coming in. It has increased from 4 to 6. Okay, so that's how the additional threads will be created since we have that configuration of max as 6, but you don't go beyond 6. Okay, and if there are if the users are if the requests are more, say now if I'm going to run it with say 10 users or 12 users, then also only the 6 will try to handle this, which means your response time is going to go up. Okay, normally um, these thread issue will come when you're going to run a stress test or a scalability test. We'll look into it later, but I'm just telling you the one of the uh, bottleneck or one of the problem could be you run a load test with say with 1,000 users, response time is good, everything is good. Then you will be planning to run a 1,500 or 2,000 2x load stress test. That time your response time will be more because the thread configuration what they might have added is maybe 500 as minimum, 800 as maximum, which could have handled the 1,000 user test. But when you go to 2,000 user test, those configuration might not be enough. Okay, so then we have to look into the thread utilization and then see if it is more than 80% or 90%. Then we'll go and ask the team to increase the thread based on few other factor as well. It is not straight away you cannot keep on increasing the thread, because it is going to get limited by CPU also. You cannot go and keep on increasing if CPU is more. Because end of the day, if your CPU is exhausted, if your memory is exhausted, even if you're going to increase thread, your performance will not improve. Okay, all these things we'll look into it detail in the JVM benchmarking. But I'm just saying the reason we are learning this thread states, how the threads are increasing, how it is dynamically getting created. All these are all the concepts behind the thread utilization. Okay, and normally interesting thing is, if you use tools like AppDynamics and Dynatrace, right? What I will do, they will provide you these alerts very smartly. Okay, if threats are not sufficient. So what I will do is I'll just stop it, and then I'll try to probably exhaust the threads by running some, say, 12 users. Okay, uh, let it stop. Okay, let's go to AppDynamics and see whether we get any alerts, or there is something called event. Again, AppDynamics also will learn it a little in detail earlier, later. Last 15 minutes, I'll take it. Okay, if you see here, already there is a event created at 8889. If you open this, that's how the tools like AppDynamics Dynatrace is going to make your job more easy. Okay, if you see here, it says that your thread pool has reached 80% limit. Current pool size is 6, max pool size is 6. Okay, so it will give you a warning. It will give you alert saying that your thread utilization is very, very high. You no need to go into the, say, if the alerts are not there, right? What you have to do, we might have to go to the particular server, go to that node, and then go to the say JMX, and then go to the say MIN browser, or rather JMX metrics. So we have to go all along to individual graphs. Okay, I'll go to the application, JVM, and then the threads. I need to check it here, or like 1 minute. Maybe I'll go to the web container runtime. Yeah, I need to go to here and then look into the busy threads, current threads, max threads. Right. That is how we monitor. We go to this JMax and go to that 8083 port and then see what is the thread utilization. Now it says that last 5 minutes it is running maximum, right? Your maximum thread is 6, current thread in pool is 6, all the 6 threads are in busy state, right? Everything in the 6 now. Max, your busy, current thread, maximum thread, everything is 6, which means everything is all the threads are used completely, right? This is how you monitor, and then say that okay, the thread utilization is very high, you need to increase the threads. Other way is AppDynamics or Dynatrace smartly provides that data in the event as well. If I go to duplicate it, this will come down after a few seconds, right? This will come down. Maybe it will take a minute to get reflected. If I again go to the event, you would have seen multiple events. Now it would have appeared. So we can create alerts, say for a heap threshold, thread utilization threshold, CPU threshold, response time threshold, so that it will appear in the your summary page, event page, for your easy troubleshooting. Okay, maybe all these things mostly will be available in most of the APM tools. Now, if I go back to the applications, if I go back to the e-library and then go to my uh, events. Okay, see, there's an event at 8:13, 8:12, 8:11, right? All these things are created for this 8083 port, saying that your thread pool has reached the 80%. Okay. Yeah, it should. Yeah, now if you see, it has come down. If you see here, your current thread, maximum thread, current thread, everything has come down to 0. Okay, nothing is no load is coming, so your busy threads has come down, and then this current thread in pool should not come down to 0 because it will be still active only. All um, 4 threads will be there. I don't know why it is showing 0. Probably we'll wait for this to get reflected properly. Yeah, but yes, the maximum busy thread has come down to 0. The busy thread will come to 0, but your current thread in pool will still be 4, which is minimum. Okay, maybe it will take some time to get the actual status of the threads. Yeah, that's how you monitor your thread through this, or the other way around is for a easy way to know whether your threads is doing good or bad. You can always look into this kind of an alerts. Okay, so we'll be learning this in detail further in the actual session. What is thread contentions, when the thread contentions will come, how to monitor the thread contentions, and then if there is a lock, if there are many locks, what it means, how to analyze those thread locks, how to take the thread dump, um, how to analyze a thread dump, how to find the root cause of the thread locks. All these things we will learn in detail. Okay. Yeah, I'll take a pass. Any of you have any questions on this or on the topics or in general? Yeah, please feel free to ask.
Yeah, hi sir, good morning.
Yeah, good morning.
Actually, I'm not getting for that in that thread
Mhm.
runnable state and waiting state.
Okay, fine. Two things here.
Yeah, this
One,
one.
yeah, two things. One is while you are running a test, okay, any load test
Yeah,
or a test
yeah,
on endurance test, we will not monitor the thread state. Okay, because it will be very exhaustive, because if you have 100 threads, 500 threads, 1000 threads will be moving between multiple states. Okay, it will move between running. If you saw that here, right, it was
yeah,
just keep on moving. Now we are just having just one, two, three users with 4 threads. It is being moving between different states. So in the ideal case, when doing a load test, we will not open this and then see what is happening. Okay, this is for our understanding of the concept. Now to tell you what is the difference, right? See, runnable or parking is, now if you see here, there is no request, right? Threads are created. All these 4 threads are created, but there is no task. There is no request coming in, right? So it is in
yeah.
a, you can call it as a parking state. You can call it as a runnable state or idle state. Okay,
Okay. Hmm.
if it is running, which means it is doing some work. There is a I'm clicking view librarian. The task has come to server. It has now received the request. Okay, since it is very fast, you didn't even see that green color here. It just went to sleep and then came back to orange. Now let's do, say, add librarian. Let me do, I don't know why it is not getting reflected. Let me close this and open it again.
And one more question is that
Yeah,
hands-on experience will be provided, right, for AppDynamics in future? I mean,
as
in
I said,
upcoming.
yes. See, um, this application, whatever we are using it, I will be providing this war file, and then you will be able to deploy it in your mission, right? And then this AppDynamics, as I said, it is in the cloud. You can set this up in your mission with your login ID also. You can register. It will ask for, it won't accept Gmail IDs, but it will accept the your organization email IDs. Or if you cannot use your organization ID, we will help you with one or two Isha IDs through which you can register, and then you can configure yourself and you can set it up on your own. Okay, that is option. Option one is you have your own email ID and register it. Two, we will provide you that email ID so that you can register. Worst case, in fact, if you don't wanted to go to that level, you don't want to configure at all, I would like you to do everything, which I will anyway teach it. If you don't want to do that, I can just give you the URL and credentials. You can open up in your browser and you can look into it. Typically, in an organization, somebody will configure it. They will just provide you the user this URL and credentials, right? That also I can give it. But yes, hands-on, I will help you to know to how to register. For you to know how to register, how to configure this with the e-library application, and then do all these hands-on by yourself. So yes, the answer is absolutely yes.
Okay, okay. Thank you.
Yeah. So yes, so coming back to your question, um, running is you there is a work there is a task coming in for the server from the browser. It will go into a running state. Those two are very clear, right? Runnable and running.
Yeah.
Yeah. In between, waiting is nothing but if you saw that gray color, right? While I was doing this login, so here now it will get a green color. Now it is in a running state. From parking, it move to running. From running, it is now going to sleeping, and again to running, again to sleeping. Again, it will come to sleeping is nothing but it is one of the waiting state. Okay. Again, it went to into parking now. So sleeping is, as I said here, from running it can go to waiting, right? So in waiting there are multiple waiting. One is the sleeping or time dot thread dot sleep. If a developer has written some code to make the thread wait, it is called sleeping. Okay, that is what you saw. It is a gray. In this tool, they have the split up. They have a sleeping, wait, and monitor. Okay, see parking we saw, which is very clear. Running we saw very clear. Other three are sleeping, wait, monitor. All three are I have classified here as waiting. Okay, this waiting is nothing but while the task is running, while the thread is actively processing a request, in between it can go to all these three different waiting: wait, monitor, or sleeping. Sleeping is nothing but a developer as a thread dot sleep. It will go to the thread will just sleep for a few seconds. That is sleeping. If it is getting blocked, if the thread is getting blocked by another thread for whatever reason, I'll explain what is blocking now later. The thread is getting blocked, it is a monitor. Okay, this wait is sometimes what happens is if the thread is waiting for some uh, Windows program to respond, if it might call some of your OS program, your Windows program or Linux program, right? Those time it will be in a wait state. Okay. Um, so that is a those are three different waiting. One is sleeping, blocking, and wait. Okay, but you will not look into how many are in running state, how many are in sleeping state. No, the one we might watch is how many are in blocked state. Okay, if when you are running a load test or stress test, sometimes what will happen is the response time will keep on increasing. Your CPU thread utilization will increasing, CPU will also increase, and you will not have any obvious bottlenecks. Your database will be doing good, your third-party servers will be doing good. There is no issue with your methods. Sometimes this kind of a scenario happens. Then we'll go and take a thread dump to see how many threads are in blocked state. Okay, and then we'll go and do a root cause analysis. So those things we'll learn it in detail later. But this is the difference of various states.
Okay.
Yeah.
And one more doubt is that in visual VM,
Mhm.
like yeah, you can just
Okay.
not in visual. Yeah, if you see here, it is not. I mean, totally now it is not in a running mode, right? So yet it is in some. I mean, consuming some percentage. 2.2 in right side.
It is overall.
Okay.
It is not currently. From the moment the thread is started, how much time it has been running is it what say 8,000 milliseconds is what it is saying, and it
Yeah.
2% is overall. When we again we no need to worry about uh, these percentages. This is see just remember think that when you're running a load test, you're going to have too many threads, too many activities happening. We will not look into this view at all for monitoring. Okay, what we will look into is the one which I saw, right? That chart. It will show that how many threads are running, what is the maximum threads, what are busy threads. That is the only thing you will monitor during a load test. If that is very high, if the response times are high, then you will go and take a thread dump. This is just for our concepts understanding. I have showed this view where I'm showing different states, and then it is showing how many seconds each thread are in running state, what is the percentage and all. It's just for our understanding. But this total is nothing but from the moment the JVM started, what is the how many seconds is this threads are running. Out of that, how many were in actually in running state. Just for this data available for our conceptually to understand this. But this is something we'll not at all use it during our load test or endurance test from a monitoring perspective. From monitoring, what we need to know is how many threads are running, how many are busy, how many are idle. That is what we will monitor from a thread perspective.
Yeah, got it. Thank you.
Yeah, thank you. Okay. I wanted to go over these a few interview questions. In fact, I'll share it later also. Maybe tomorrow I'll go over this. I'll share it in the group chat also. See, these are some of the common interview questions that uh, you might encounter, and you can just go through this offline. And most of these is what we would have tried to cover it from a topic as well, right? So that you will be able to answer all these questions very easily. Okay, I'll share this maybe in a slide, not in a slide, maybe in a sheet sometime today. You can go over that, and then I'll also go over this few questions and answers tomorrow for just for your understanding. Okay, but from tomorrow we'll get started with the session number one, right? We'll start with the basics of Java, and then programming of Java, and then JVM. We'll get started from tomorrow. Okay, so any of you have any questions on the topics, content, please reach out to me the daytime today through WhatsApp. Message me, we can get into a call if you have any questions. For any registrations related questions, any payment related question, you can reach out to Kumar sir or the admins in that WhatsApp group. Okay, I'm just repeating the same thing. These sessions are going to be same time what we have connected today, 7:30 to 8:30 a.m. IST. Okay, I'll stop it here, guys. Any other final questions before we wind up for today?
Hi, I have one question.
Yeah,
In this
please.
course, do you help how to set up the CI/CD pipelines for running the load test?
See, as I told you, right, this course is tailored for engineering. Setting up the pipeline for load test. Um, in the introduction to DevOps, I'll be teaching you what are the best practices you should follow. It can be any pipeline. It can be your Azure DevOps pipeline or a Jenkins. The creation of the pipeline, creating a job is something varies from this tool to tool, and mostly the DevOps team will do it. Our job as a performance testers or engineer is to make our script, make our scenario ready, prepare it in such a way that it is going to work stable in the pipeline. So I'll explain you what are these best practices, how to, what are the things that you need to consider when you plan to run it in the continuous testing pipeline from test data perspective, from an environment perspective, from the downstream services, selecting the scripts for this regression scenario. So all these best practices for making your load test successful in the pipeline, that I will teach you. I'll teach you how to create maybe a Jmeter scenario in Jenkins. Those things I'll teach you. But when you say creating a pipeline, right? Uh, that is something we don't need to really worry about it, because number one, it is a job of DevOps team, because they are going to create a job pipeline for your deployments, creating a build, and then running a smoke test, running the functional regression, running the security testing. All these things will be taken care by the DevOps team. Similarly, for if you give a requirement, they will do it. Even otherwise, if you wanted to create a simple pipeline for performance testing also, it is going to be tool dependent. It's something very going to be straightforward. But what I will
I'm
teach is the
okay.
one what I
Go
told.
ahead. Go ahead.
Yeah, yeah, yeah. No, what I told, what I explained you is what I will teach, which will be in generic for any tool like Jenkins or ADO or TeamCity. That is what I will teach you in general. How should you address? How should you prepare for running your scenarios in the pipeline?
Okay. And
Which is very
you're not going to cover anything related to the .NET performance engineering or anything, right?
correct. Yeah. .NET and Azure, as I told earlier, since there are few requests, what we will do is we will try to probably create a small uh, uh, 3 or 4 sessions very specific to addressing the .NET and the Azure. Not now immediately, maybe in a month or two, we will try to create and send it across those videos to the this group. Okay, which is not going to be part of the session, but it will be done in the upcoming months. That we will do it since there are multiple requests coming in.
Okay. And one last question, related to the course, how many weeks is this course? Like, how many hours? Like this training specifically for the performance engineering?
Mostly it will go over 22, 23, 25 hours. So spread it across say 5 weeks.
Okay.
Okay. Fine, we'll stop it here. Since still, if you have any questions, we can definitely connect over the call today. Anytime, just message me. Based on our mutual availability, we can connect. Okay, see you all tomorrow.
Thank you.
Yeah,
Yeah,
thank you.
thank you.
Yeah, thanks, Satish.